तो इस लेक्चर में हम डिस्कस करेंगे डेरिवेटिव ऑफ द फंक्शन ऑफ मोर देन वन वेरिएबल. So let us recall, for a function of one variable, that is, if you have a function f from R to R, and if it is differentiable at a point A in R, then if this limit exists, suppose f is differentiable at a point A, then what happens? This limit of the quotient f of a plus h minus f of a upon h, this limit when h tends to 0, this exists. If this limit exists, we say that the function is differentiable at a point A, and the limit of this quotient is called f dash a. So f dash a, the derivative of f at a point A, is actually this limit. Alright, now in order to generalize this idea for function of two variables, you can see that this definition will fail. It won't work. Because in that case, if you consider a function from say R2 to R, or some region of R2 to R, and you apply the same definition and think of the limit of this quotient f of a plus h minus f of a upon h as h tends to 0, this will not make any sense, because in this case this scalar, this h is no more a scalar, it's a point of R2, and that means it's a vector quantity, and this dividing by a vector quantity will not make sense. So the derivative, the idea of derivative in this case, in this manner, will fail. So this definition will not work. So you can suggest me that if I replace h by modulus of h, perhaps this will work, but even that will fail. Okay, so I will explain you how this definition will fail even if you make this denominator as mod of h. So let us try to generalize this definition for function of more than one variable. So look here, suppose I have a function f from R to R, and it is differentiable at a point A. If f is differentiable at a point A, I will consider a new function eta A. It's a function of a scalar h. Let us define it like this: f of a plus h minus f of a upon h minus f dash a when h is non-zero, and 0 when h equal to 0. So this is a function which I am defining. Now look, whenever f is differentiable at a point A, this function eta A, you can notice, is continuous at a point 0. So if f is differentiable at A, if f is differentiable at A, then eta A is continuous at 0. It is easy to realize. In fact, not only this, the other way around is also true. If you define for a given function f and a real number a, if I define a function eta A given by f of a plus h minus f of a upon h minus some scalar lambda when h is equal to 0. Suppose I have a scalar lambda such that the function eta A is continuous at h equal to 0, then you can see that this function f will have a derivative at the point A, and in this case f dash a is precisely lambda. So my statement is true from both sides. अगर फंक्शन डिफरेंशिएबल है तो ये फंक्शन ईटा ए जो है वो कंटिन्यूस होगा, और अगर मेरे पास कोई स्केलर लैम्डा है such that this function is continuous at a point h equal to 0, then the function will be differentiable at the point A. So this function is important to us. So we will look into the definition of derivative in terms of this eta A. And you can see it is what? It is actually the difference of the derivative and this quantity. Alright. Now this quantity you can see graphically also. So geometrically speaking, when you think of the derivative of a function from R to R, its graph is always a curve. Suppose I have a point A over here in the domain of the function, choose another point A plus something h, then you can see that in this triangle, this is f of A plus h minus f of A. And this much is h. So you have this triangle, you may call it ABC. So ABC is a right triangle, and tan theta, if I consider this angle as theta, then tan theta is actually f of A plus h minus fa upon h. Alright, now when h tends to 0, what will happen over here, that the point B will move towards the point A. So in the limiting case, when h tends to 0, the chord AB will become a tangent at the point A. Suppose this tangent makes an angle phi from the x-axis. You just extend this tangent line further and extend this line also. So tan phi in this triangle is equal to BC upon h. Okay. Now look at this. Let me rewrite down this definition. Over here. So eta AH, if I call this definition as definition star, so star can be written as f of A plus h minus fa or equal to fa plus h times f dash A plus eta AH into h. Okay. Because I will be considering functions from R2 to R, so let me make it modulus of h. Okay. So you can read this definition as follows. A function is differentiable at a point A if there exists a continuous function eta A such that f of A plus h equal to this. So this function is continuous at 0. Moreover, over here if you look at this middle term, it's a linear function of h. Why it's a linear function of h? Because it's a constant time h, so it's a linear function of h. Okay, so you can call this linear function of h as dfah. Okay, so what is dfah? Dfah is f dash a times h. It's a linear function of h. So I will read it like this. A function f is differentiable at a point A if there exists a linear function dfah such that f of A plus h, let me write down the left hand side also. What is this? This is f of A plus h minus f of A, and the right side will be equal to dfah plus eta AH into modulus of h. Or you can further rewrite it as delta FAH It is in fact the nonlinear change in f, because when you go from a to a plus h, this is the difference in the values. So you are traveling along the curve, so I am calling it a nonlinear change in f. And whereas this right side is this dfah, it is a linear change in f. Okay, this is a linear change and this is the difference. It is equal to eta ah into h. Or from here I can say that delta fah minus dfah upon h, or modulus of h, is eta ah. Okay?
Over mod of h.
Mod of h you can write down mod of h.
No. Non-linear chain means we can say it's an increment.
Non-linear change increment in h. When you go from point A to point B, yes, what is the change in the values? Okay, so this is the non-linear change. You have written it here, so this is delta f h. Now I am looking at the triangle A, and if you call it ADC. If you look at the triangle ADC, what you will see that tan phi equal to BC, tan phi is, this is tan phi is not BC. Oh, B was this. I'm sorry. Okay, B was this. Okay, so this is BC. So this is, so H into tan phi equal to BC. And tan phi you are calling as, in the limiting case, as f dash a. So h times f dash a equal to BC. This is to be seen. Tan phi is what? Tan phi is equal to what? Tan phi equal to BC upon h. Am I right? This is phi. So BC upon h. So this is tan phi equal to BC upon h, and this is also f dash a. Yes. Tan phi is f dash a, slopes. Yes. So BC is this, and this is in fact dfah. Okay, and the difference between the two, so this is delta fah and this is dfah. So for the existence of the derivative, what in fact you are demanding, that the difference between the two, this minus this, okay, that means this much should tend towards 0 faster than h. When you say that this is a continuous function, means this must be 0 when h tends towards 0. Okay, so sometime you also write it down as OH. So basically बात ये है कि हम अगर डेरिवेटिव को रिविजिट करें तो हम ये देखते हैं कि एक्चुअली डेरिवेटिव जब ही एग्जिस्ट करता है जब नॉन लीनियर चेंज और लीनियर चेंज के बीच का डिफरेंस जो है वो ज़ीरो की तरफ ज़्यादा तेज़ी से जाता है बमुकाबले h के, बिकॉज h is also tending towards 0, this is also tending towards 0. So what we wish that this should tend towards 0 faster than h in the case when the function is differentiable at the point A. So this is one observation. Okay, the derivative means the difference between the linear change and the non-linear change should tend towards 0 faster than h.
But the non-linear change actually is also true change. True change, sir.
True change. True change.
True change.
Yes.
That is the estimated change.
Exactly.
So that ratio should be very less.
Yes.
That's why error should be very less.
Error should tend towards 0 faster than the h. Yes. Okay. You see, if you consider a function, instead of considering function from R to R, even if you consider a function from R to R2, this definition will work. There will be no problem. You see, let me write down this quotient f of a plus h minus f of a upon h. Now look at this quotient. It is still meaningful, because now in this case f of a plus h will be a vector in R2. This is also a vector. This is the difference of the two vector, and you are dividing it by a scalar. So this is meaningful. I can also think of its limit h tending towards 0. What will happen now? Whatever, if this limit exists, I will still call it f dash a. But since the right side is a vector quantity, a vector divided by a scalar is a vector quantity. So in the limiting case also it will be a vector quantity. So the derivative in this case of f at a point a will be some vector. Is it right? Yes. And if you see again the same definition, what I would want that the difference between the linear chain and the nonlinear chain should tend towards 0 faster than h. Okay, so in this case, when your function is from R to R2, let me draw the figure again. So, okay, I stop for a while.